Hello, everyone. My name is Praful. I run this company called Coseer. We are essentially a cognitive automation software that can accelerate workflows in enterprises and then hence accelerate the growth. Thanks a ton for your time today. So today I want to talk about a bit of introduction to Coseer, and I also want to talk about later on about the key Coseer capabilities. Coseer essentially brings artificial intelligence to natural language programming and uses that capability to automate any natural language driven workflows. The traditional artificial intelligence is more geared towards structured information or information that is completely available in some form of tables. But to take that into a completely unstructured domain like natural language takes a lot of work. This is what is called cognitive computing. And you must have heard this term, particularly IBM Watson is actually promoting it very heavily. We are essentially playing in that same space. The kind of workflows that we usually automate, and we'll talk much more about it, are essentially answering questions from specific documents or synthesizing millions of documents or a single document into summaries or scorecards, or extracting structured knowledge from unstructured and nebulous text, or redacting sensitive information automatically. Later in the presentation, I will talk about some of these capabilities at a greater depth. We have been very fortunate to have been recognized by the industry, and we are very grateful for that as well. I hope today we can impress you as well. I'll be talking about various capabilities. Some of them may not be directly applicable to your particular use case or your particular sector, but then it all presents a cohesive picture of what Coseer can do and how we use cognitive computing to automate workflows. The first thing I want to talk about is an implementation we have done in the finance sector, where we synthesize 3 million different articles every day related to stocks and then create actionable trading insights. Essentially, if you think about the building blocks of the solution, there's an ingester. We support 6 different formats over here. Writing APIs for new formats is usually not a hard task. Then a prioritizer, which basically takes all this information extracts all the relevant insights from each of these documents, deduplicates, and prioritizes them as per the particular actionability model. In this case, the prioritization is done around how important is that particular piece of information in terms of creating a trade. The model for your use case or for your industry could be completely different, and the same models could be trained for that particular purpose. And then once that is done, everything is collated together in a personalized report. If you look at this screen, this is what an individual screen will look like, where you can add stocks or topics or other things that you want to track. So let's go into a particular stock. The tool has ingested 6,700 documents just related to Apple over the last week and has given out about 10 to 15 different bullet points. Each of these bullet points is actually attributable to a source. And the ratio is actually different for different things. So for example, this is recorded at a time when Amazon just acquired Whole Foods. Of course, there's a lot more news around it, even though the number of documents is only 3,000. Each of these bullet points has been rated as per an actionability criteria. So for example, if you click on the actionable only news, then you can see that the news related to the acquisition comes up right at the top. Particularly news around the fact that the Whole Foods valuation may not be complete and the price may go up. Similarly, you can have the portfolio view to get just the training data over the last day. That was the synthesis case study. Next case study I want to present to you is around natural language search or chatbots, which work differently with contextual training. The way this use case works is essentially we train a cognitive machine for context. We use base corpus document, we use glossaries and dictionaries, we use secondary corpus documents if available, other contextual documents. So for example, even the case study I presented before for finance, we had to train for context with only financial documents. What this training does is build cognitive models out of the base corpus. And cognitive model is an understanding of a document as a human would understand it rather than as just as a collection of letters and numbers. I don't want to go into too much technical depth over here. Essentially, think of it as capturing all the ideas and information contained in the document and ranking them as per importance. Because once you do that, then you can support multiple applications based on those cognitive models. For example, natural language search or chatbots. I mean, it's a fad right now. Uh, I personally think a lot of these chatbots will go away over time, but right now it's everyone wants to use chatbot for various purposes, and that can be supported. These things can be supported using APIs or IT integrations that have nothing to do with the UX. It can be white labeled into your existing workflow or existing IT systems and give the same capabilities. For example, to prepare for this presentation, we put together about 50 or so consulting documents in it. And if you ask a question like, okay, tell me about trends in media, this automatically identifies the documents which have information around here, and it will give you the best answer. However, the chatbot interface may not be the best interface for this. So it essentially wraps a traditional search interface where all the snippets are extracted and put together on a single screen. If you click on a snippet, you get to the actual source of where that information has come from. So for example, in this case, the computer decided that this is the best information around that particular query that you put in. The advantage of this kind of a structure is that you can add multiple value added things on top of it. So for example, you can say, I don't want the documents. I want just the authors of the documents because these authors are likely to be experts in those domains. These are made up names, but I hope you get the idea. So you can essentially have a configuration suite over there built upon the basic capability. You can actually automate a bunch of other workflows. The advantage of the chatbot interface over here is that interactively it can hone down to the exact query that you want. So for example, if you do some generic query, it can ask you to be more specific before it goes into actually giving you the answers. Not that if you did a generic query, again, if you go back to traditional search interface, if it found 1,000 documents out of the corpus, it will still show you those 1,000 documents, but they won't be as relevant. Let me also show you the redaction feature that we have inbuilt or we support using the natural language search process. If there's redaction, if that is happening, that means that you can really sanitize every piece of information that you have and take out every client specific information, every personally identifiable information, and automatically put it into a knowledge management system, taking it to the next level. The third advantage of the chatbot interface is really that if you are looking for just a specific information, let's say you saw it somewhere, now you can't find it, you can just type in the specific query. For example, here, if you were looking for USPS manpower reduction, this is a chart you wanted, and you could get it in a single click. By the way, and just to emphasize on the cognitive powers in it, the manpower is not on this document anywhere. So it's not a keyword matching at all. Computer figured out that manpower means workforce, and actually was searching for workforce as well when it answered the question. And these kind of association, as we go deeper into technical, maybe in a later conversation, these kind of associations are very context specific and are trained into the Coseer system using glossaries, using co-occurrence, and many other such techniques. The last use case, and I promise this will be quick, is essentially extracting data from nebulous text. So this is an implementation done for a a GPO or a company that fronts hospitals in their purchases. What we did was ingested 35 million documents like surgical protocols, white papers, or product brochures, and built cognitive models from them, as we saw earlier, and then annotated the whole document in terms of the structures that were inherent. We're talking about key value pairs, we are talking about actions and questions and diagnoses, we're talking about relationships, we're talking about sentiments, any kind of structure that was explicit in there, because then that structure could be used to bring out the tables like this, or databases, or auto-populate those databases or other tables. So in this case, for example, the the right-hand side as well as the left-hand side of the tables were figured out automatically. Not only the values, also the attributes for which the values were needed. And of course, we did it for 10 million different times. This is the sample output from this system. Essentially, you have all the part numbers and manufacturer name here. The system automatically classified into different categories, the bag of parts into different categories like tubes and kits. And for each category, figured out the right attributes and filled them, some more than the others. And essentially, the whole input, which was just a part number and manufacturer's name, was converted into some useful data for further processing. So I hope you have a good understanding of the capabilities of Coseer. Let me recap it. Essentially, we can extract knowledge that is explicit in the underlying corpus. We can convert that knowledge into ideas so that it becomes much easier to explore it in a very intuitive and cognitive way. And once we have those ideas, as well as all the knowledge that can be explicitly extracted, then we can synthesize it or put it in a different structure to be further processed. Please keep in mind that while the case studies that I presented or the workflows that we in general automate look very disparate on the face of it, the code that is running it is exactly the same. The capabilities that go in automating each of these workflow there's a huge overlap in those capabilities. And the point of view that we have taken is that once there is a cognitive automation opportunity, then anything else around it, the ingesters, the interfaces, the data pipes, all that is not trivial, but it's very doable. There's no uncertainty around it. The APIs can be written very easily. The web pages and user interfaces can be created very easily, even though it takes time. And that is how we are automating one workflow at a time. Coseer has been designed to solve for the key friction points with cognitive computing. There's a lot of hype around it. There's a lot of expectation around it, but adoption of cognitive computing today is not very easy unless you use a tactical software like Coseer. So for example, we train for a very specific context and a very specific problem. And that is how we are able to get a very high accuracy of 95 to 98%, which is what is acceptable to businesses. In a consumer world, maybe a lower accuracy can fly, but for businesses, it doesn't. And the way we know it is that we keep auditing our live systems. And that is how we know these are the numbers from those audits. These are not just made in air numbers. Similarly, there's a big need that we have obviated, which is the need to pre-tag the training data before artificial intelligence system can be made. Our engine has been designed for natural language or unstructured information, and hence you don't need any kind of pre-tagging of data or create or impose a structure on it, and hence our deployment can be as quick as 4 to 12 weeks in simple cases. Similarly, the software has been designed with complete data security in mind. It's a Java-based software. It can be hosted on our cloud as well as your cloud. It's a single-tenant software. Your data does not get commingled with anyone else, and all the security requirements that you have around your data are completely complied to. Most importantly, once the engine goes live, even the Coseer team does not have any access to your data. And for all these reasons, it has become very tactical in the sense that the software is applicable to small problems faced by individual teams as well as enterprise class problems. We are not out there to cure cancer. We are just out there to take one workflow at a time and automate it to milliseconds rather than days or weeks it takes today. Thanks a lot for your time today. I'm always up for more questions or follow on discussions. Appreciate it.